I am Dr. Kishore Koparkar. I am the corresponding of this research work. My topic is a synthesis and photoluminescence property of YVO4 U3 plus and the YVO4 U3 plus cap with SiO2 for biological application. These are my content: abstract, introduction, experimental section, result and discussion, FE same, photoluminescence study, HeLa cell, cytotoxicity, conclusions, acknowledgements, and references. Abstract of this work is a red emitting U-dope YVO4 phosphate synthesized by using co-precipitation method. The core cell structure of YVO4 cap with SiO2 was obtained by using TOS to improve the biological application properties. The structure, conformation, and morphological property of asynthesis material were investigated by using XRD, field effect scanning, electron microscopy, photoluminescence study. In this photoluminescence study, we can see that this material was studied using photo spectrometer, which reveals that intense red emission corresponding to 5D0 to 7F2 transition of U3 plus ion in the host lattice under a particular UV excitation. Biology compatibility of asynthetic material shows the good potential for biological application. These are my keywords. Introduction of this research work is my phosphor is YVO4 U3 plus is one of the best and very demanding phosphor in the field of luminescence. This is the commercial phosphor because of high chemical and thermal stability as well as low photon energy also. The quantum efficiency of this material is very high. The phosphor is an important commercial rate emitting phosphor in the field of display application. In the recent year, this phosphor core shell of SiO2 are widely used for various applications. Silica shell can increase the photochemical and the chemical stability of the core particle. In this, TOS used for the capping. Most of the researchers use Sol-Gel method, pitching method, but in this my work, I inspire and modified by using novel method. So, it's called as co-precipitation method. Co-precipitation method is very easy, low cost method, and the additive of this method, chemical additive is in this method is used is very low cost, so that the material becomes a very low cost material. Experimental session, co-precipitation method is required oxide. So this oxide mix in China clay basin. A small quantity of water added in HNO3 was added drop by drop and heated at 50 degrees Celsius. After that, the solution was further heated to get excess of acid boiled off. The resulting of solution was considered as YNO33 EU3 plus. To this, the precipitation so obtained filtered out, washed with deionized water and acetone, and dried at 50 degrees Celsius. The final product of YVO3 plus heated or calcined at 900 degrees Celsius. The preparation of YVO4 cap with SiO2 core shell is as follows. The YVO4 U3 plus with 20 ml of deionized water sonicated for 30 minutes, then silica shell cap or YVO4 U3 plus were prepared by hydrolysis of TOS as an alcohol solvent in the presence of water with ammonia was added drop by drop in the solution of YVO4 EU3 plus. The mixture was stirred 30 minutes and aggregated using ultrasonication for 1 hour, disperse the core particle. The reaction was continuing in the ultrasonication to obtain more dispersed core and uniform SiO2 coating on the core. Then we got a YVO4 EU3 plus cap with SiO2 particle were formed. Result and discussion section. XRD, this is the XRD of my material. Above graph shows that the XRD pattern of our research work, and the below part of the XRD is a standard ICD file, and we can see that our work is 100% matched with the ICD file. This is the FE graph. The A graph shows that our YVO4 U3 plus, and the second graph B graph shows that the spherical particle. We can say that after coating SiO2 on the YVO4 U3 particle, the particle size of YVO4 VO4 U3 plus at the rate SiO2 core shell becomes increased with spherical nature as shown in figure B. This is a small animation of this my research work. This is the excitation host lattice excite my material and emit in the particular red color. In the second diagram, this excitation gives sensitizer and sensitizer transfers its energy to activator and activator gives emission in the red color, intense red color. So this is the photoluminescence phenomena. This is the photoluminescence spectra, excitation and emission spectra. This is the emission at highest peak at 6 to 1 nanometer. We can excited by 318 nanometer wavelength. So we can see that YVO4 U3 plus cap SiO2 is gives a intense high intensity as compared to the YVO4 U3 plus. This is the another characterization of my research work. HeLa cell cytotoxicity and drug release property of YVO4 cap with SiO2 material. So we can see that the this graph, by varying the concentration we can measure the toxicity. We can see that in figure it is clear that the assay result demonstrate the YVO4 cap with SiO2 was almost no toxicity upon incubation with HeLa cell. The viability of HeLa cell vary with increased concentration. Thus, it is found that the prepared samples show no cytotoxicity using the MTT array. Conclusion: YVO4 is synthesized by co-precipitation method, which is low cost, low temperature, and not required any another additive for initiate or process of synthesis. The YVO4 cap with SiO2 shows optimum PL emission than YVO4 U3 plus phosphor. Secondly, often YVO4 cap with SiO2 core shell phosphor has spherical morphology, sub-micron in the range of nanometer, and narrow size distribution. The cytotoxicity test of as paper sample indicate that the YVO4 U3 plus particle cap with SiO2 shows the no cytotoxicity. Moreover, our strategy develop other core shell yttrium based phosphor in the future. This is the future demanding commercial phosphor. Acknowledgement, and these are my references of my research work. Thank you very much.